Hey guys, welcome back. Welcome to the day two. Hey guys, welcome to the day two of our 30 days YouTube challenge. So in this day two, we are going to look at what thermodynamics basic calculation. If you are doing thermodynamics here, uh, probably you want to learn the fundamentals calculation before you start moving to the advanced calculation aspect. So in this video here, we are going to look at the pressure volume work calculation. How you can calculate work when it comes to what pressure volume work. They will also look at material, look at what isothermal reversible expansion of an ideal gas. They will look at what change in internal what energy. Then we have to look at so many calculations, close to like 10 to 15 calculations. Now, as we move along, as I follow, make sure you follow through the video and make sure you have your pen, your calculator, and you're able to take down every single thing. And if there's any question I say you should do, probably make sure you try that because that is how you learn. You learn that the easiest way to learn something is to actually do something. So as I'm solving, then you yourself be following, then pause the video and attempt any question you want to attempt. That is how you can what follow through. If you have any question, only leave it at the comment section. Okay, so the first one to look at is what is pressure volume work. Pressure volume work. Is okay. Now, this one here, work is equals to what P change what in volume here. So now I have done a complete video where I talk about the basic concepts. What is thermodynamics, the definition of thermodynamics, what is system, what is surrounding, what is boundary, type of process, the isothermal process, the adiabatic process, the isochoric process, isobaric process. We have done those calculations, we have done those things in my previous video. So you can check out previous video or it will be at the description below. You want to what master the basic concept. Do you understand? So now W, which is the work done, equals to P change B. It's called pressure volume work. So when a calculation is being given to you, I have been giving you what the pressure of the gas and the volume is okay. Now, when work is done on this, work can either be done on the system or by the system. So we can either have what expansion. Because you can either have expansion. In expansion, work is done by the system. So you have work done by the system. It's okay. And when work done by the system, it is what? It is always negative. So expansion, work done by the system on the surrounding. Now it's always what? Negative. So you have W equals to minus P change what in V. It's very important to what know this. So this work done by itself is called expansion. We also have what called compression. So that what we call compression, actually a compressive system. Now here work is done on the system. Here we have work is done on the what? On the system. It's okay. Now when work is done on the system, it is what? It is positive. So here we have W is supposed to what? Plus P change what in V. Do you understand? So if you look at it very well, now the work done W equals to what? Work done, and it must be in what? In joules or what? Calories. It's okay. It must be in what? In joules or what? Calories. So 1 calories is only equal to 4.18 what? Joules. So this way you are converting what? For calories to joules or for joules to what? To calories. You have to make it of it. Because most times they will say express your answer in what? In joules and what? In calories. Now P is what? Is the pressure of the gas, and it must be in what? In ATM. So whatever the volume that is being given to you in that calculation, you need to convert to ATM. You understand? Then change in V is equals to what? V2 minus what? V1, and which is what? V is equals to what? Volume. and it must be what in liter or what dm cube. It's okay. Now there's one conversion after you use it here, because if for example now you are using W equals what pressure times volume, right? Now the unit of pressure is what? The unit of pressure is what? Is atm, right? And unit of volume is what? Is liter. It's okay. Now in your calculation you always get atm liter, but the unit of work is not atm liter. So if you say that you always convert atm liter to what? To joules. And there's what? There's a unit you can, there's a conversion factor you can use. So here we have 1 atm liter is equals to what? 101.33 what? Joules. These things are what? These conversion factors or conversion, the relationship here are very key when you are solving questions when it comes to what? Pressure, volume, what? Work. You get? So we have to take some calculation now. We have to take some calculation now. So let's look about these two questions. So one is expansion, one is compression. Now let's see how we have to what, tackle them. You get? Understand that W is equals to what? Minus P change V. This is called what? This is called what? Expansion. It's called what? Expansion, right? And here we have W equals to plus P change V. It's called what? Compression. Are you there? What it means that the final unit, the final sign here, understand here, that the final sign must be negative, and the final sign must be what? Positive. You get? So the final the value of work you're going to get will be a positive sign in compression, and the final sign in compression is going to be what? Negative when it comes to what? Work done. So now let's start with the first one. You say how much work is performed by a gas as it expands from 25 liter to what? 45 liter against a constant external pressure at 1.6 atm. Solution. Look at what the question one, the solution. So if you check it very well, now I have what? V1. My V1 is what? My 25 watts liter, right? Those are what? My V2. My V2 is what? 45 watts liter, right? Then I also have what? My pressure. My pressure I have what? 1.6 atm. Then the work done. It's okay. Now because they say what? Expansion. Now expand. So my final value of work must be negative because the final value of work here is going to be negative. So if I use first one here, W equals to minus P change in V, right? Now remember here we have what? Minus P V2 minus what? V1, right? So now let's plug our values. If you plug our W here, it's going to be what? Minus P is what? 1.6 atm times. Now V2 is what? 45 minus what? 25 liter, right? Check it very well. So what will happen here? So it's going to be minus 1.6 atm times 45 minus 25. Here we have what? 20. So it's going to be 20 watts liter. So if you multiply them, here we have 1.6 times 20. Here we have minus what? 32 atm watt liter, right? Atm watt liter. So we want to convert what? Atm liter to what? To joules. Converting atm liter to what? To joules, because the unit of work is not atm liter, rather is what? Is joules. So we use this conversion factor here, which is what? 1 atm liter equals to 101.3 joules, right? So we're going to do what? W equals to what? Minus 32 atm liter times. So this will come to down. So if we have 101.33 joules over 1 atm liter. The reason that so this you cancel out this one here. So what do you have? So 32 times 101.33. 32 times 101.33. Here we have minus. Remember, there's a minus sign here, right? Minus 3 to 42.56. So it now being what in joules. Now you can convert it to what to kilojoules, right? I divide by what 1,000. If you divide by 1,000, here we have 1, 2, 3. Going to be minus 3.24256 kilojoules. That is the what answer. Again, this is what is the answer. Now, what about if they should ask now to convert to calories? Convert this one to what to calories. So if I should write this place here, if I be asked to convert to calories, so that is my work, my W is equals to what? Minus 3242.56 what joules, right? So now let's say you want to convert to calories. How do you convert to calories? Remember, there's a relation between calories and what and joules. The relationship is 1 calories equals to what? 4.18 what joules, right? This is what the relation between calories and what and joules. So if you are converting it, it's very easy. Here we have W equals to minus 3242.56 joules times. So calories will be at the top, right? Then joules will be at the down. So here we have 4.18 what joules. Because of joules, we cancel out joules, right? So what you have here, you're going to be minus 3242.56 times 1 calories over what? 4.18. So let's look at it. 3242.56 divided by 4 points. Here we have points of 4.18. So we have minus 58.02 watts, 03 watts calories. That is the answer. You understand? Now you can see that. Now it's an expansion. It's an expansion. It's for now the unit I have here is what minus. Yeah. The sign. Sorry, the sign I have here is what is minus. So when it comes to expansion, the work will always be what negative. Do you understand? How about question 2? They say how much work is required to compress a gas from 50 liter to 35 liter at constant pressure of 6 atm. Now they say compress, right? Now because they say compress, my work must be positive. My final work must be what? Positive. You get? So there's my V1. My V1 is what? Is 50 liter. My V2 is what? Is 35 watts liter, right? My pressure, so my pressure is what? Is 6 atm. Then my work done. Now, at first, because they say compression, what happened here? So many people will use this guy, right? But if you should use it, now let's use from here. Let's see if our work will be positive at the final answer. Do you understand? So let's use this guy. W equals what? Plus P change V, right? Because they say compression. You can see it, compression. So if you look at it, we're going to be plus P V2 minus what? V1, right? So if you plug in your values, W equals of my plus, right? 6 atm times V2 is what? Is 35 minus V1 is what? Is 50 only what in liter, right? So what will happen here? We're going to be what? Plus 6 atm times going to be what? 50 minus 35 minus 50. 35 minus 50 should be what? Minus 15. So here I have what? Minus 15 watts atm. So minus 15 watts liter, right? So what will happen here? Going to be 6 times 15 times 15. Here I have what? Minus 90. Minus what? 90 atm watts liter. Do you get? So from here I cannot convert. But they say compression, and it should be what? Negative. It should be what? Positive, right? Compression, the final sign should be what? Negative. Because it's compression, it should be what? It should be what? Positive. But it should be what? Positive. You get? But it's not positive at this point. So what are you going to do here? then it means that you cannot use this formula here. Rather, you are going to use minus and what? Minus and what? Minus. It's okay. Then you are using what this formula also. You get, so minus times minus is going to be what? Plus. Can you see that? From here, now I can talk about what ATM liter to what? To joules. Understand that 1 ATM liter equals to what? 101.33 what? Joules, right? So now it will be what? W equals what? Plus 90 ATM liter times. Here we have 1 ATM liter, 101.33 joules, right? So here you can cancel this one here. So here you have this one. Here you have 90 times 101.33. So here I have 9 plus 9119.7 joules. That is the what answer. But hope you understand now. So this how to work solve pressure volume work. So now move to the next one, which is called isothermal reversible expansion of what? ID gas. So that will be the next thing I want to look at. Now let's move over to what? Isothermal reversible expansion of an ID gas. It's also what? The work done. Yes. So we are looking at what pressure volume work when we relate W equals to what? P change volume, right? Now, when we talk about isothermal reversible, it means at constant temperature, and the temperature must be given to you. Do you get that? So when you know the temperature of the gas, you use what? The isothermal reversible expansion of isothermal reversible expansion of an ID gas. So now, here we have W here. It was what? NRT ln V2 or what? V1. Mind you, this formula here is derived from this one here. P change one in P. It is being derived from this other one here. But I'm not showing you how to derive it. You understand? I'm not showing you how to derive it, but you understand that when we talk about isothermal reversible expansion of an energy gas, the formula to use when it comes to what the work done is what? NRT ln V2 by what? V1. Now, this is what is the work done. N is what? N equals to what? Numbers of what? Of moles. Numbers of what? Of moles. R is what? Is the gas constant, which is what? 8.314 joules per mole per what? Kelvin. It's okay. Joules per mole per Kelvin. Now, temperature must be in what? In Kelvin. T is what? Is temperature. In temperature, which will be in Kelvin. I know that if the temperature be given to you in Celsius scale, you used to what to convert to what to the Kelvin scale. But I do what 273. Do you understand? Then V2 equals what? Final volume. Final what? Volume. V1 is supposed to what? Initial what? Volume. It's okay. So how do you know when to use this one, and how do you know when to use this one here? Now, you use this one when the temperature of the gas is not being given to you. You get, so probably when you're being given only the pressure of the gas and what volume of the gas, that will use one here. But this one here, there will be what additional what values given to you, like temperature and the moles. You get, that is how to easily what differentiate how to use this one and how to use this one here. Do you understand? Now, we want to derive this one here. Recall, if you should recall in what Boyle's law, we know that P1 V1 equals to what? P2 V2, right? Now, if we should reduce this one, if we should reduce what? This is Boyle's law. Now, in Boyle's law, as pressure increases or volume decreases, it's inversely. Volume is inversely proportional to what? To pressure. So, if we should reduce it here, you have V2 about V1. You have what? P1 about what? P2. It's okay. Now, this one is also the same to this other one here. Now, because if you cross multiply, you go back to this guy. Do you understand? So now it means that in my Boyle's law formula, V2 or V1 equals to what? P1 or P2. Now I can write this one here, and I see my V2 or V1, I'll put P1 or P2. So it means that here I have W equals to what? NRT ln P1 or P2. Do you understand? So these are the two formulas what we are using in this calculation here. Now, but we are talking about expansion. Then remember, in expansion, W is always what? Negative. Do you understand? So it means that when I talk about expansion here, that is my W equals minus N arrow T ln V2 about V1, right? Then let me write it to then W equals to what? Minus N arrow T ln P1 over P2. It's okay. So these are stuff you are going to what? Make use of. So we are going to look at so many examples and questions so that you understand how to use this formula in calculating what work done. It tells you what isothermal reversible expansion of what of an ideal gas. So let's get into those questions. Now let's solve three major questions. So I will solve this one, then you are going to try this one for me and leave your answer in the comment section. Then we have to solve this one together. It's okay. Please, if you can see the board, clearly tell me that you can see the board. But if you cannot see the board, tell me on the comment section that you can't see the board. So I'll know what to do next time. Do you understand? So let's look at the question. Let's start. 1 moles of an ideal gas at 25 degrees centigrade. So numbers of moles is what? Is 1 mole. At times it can be 2 moles, can be 3 moles, can be 5 moles, right? Depending on the value of the mole. But here they say what? 1 mole. Now, 1 mole of an ideal gas at 25 degrees centigrade. That is my T is what? 25. Is okay. Degrees centigrade. Remember, I must convert what? Centigrade to what? To Kelvin by adding what? 273. So if you convert what? The Kelvin, the Celsius scale to, if you convert what? The Celsius scale to Kelvin scale, it's going to be 25 plus what? 273. What is the answer? It's going to be 25 plus 273. Here we have 298 Kelvin. You see that? Now, it's allowed to expand at a constant temperature for a volume of, so 10 liter to what? 20 liter. So the volume, so my V1 is what? Is 10 liter. My V2 is what? Is 20 what? Liter. They're asking what is the work done? It's okay. What is the work done? So it's going to be a isothermal reversible of an ideal gas. So it's going to be W equals to minus N R T ln V2 about V1, right? Now remember, when gas constant is what? 8.314. So remember, R is always equal to 8.314 joules per mole per watt per Kelvin. Is it okay? Joules per mole per watt per Kelvin. That is it. So if you should input your values, my W here equals what? Minus 1 times 8.314 times my temperature is what? 298. The ln, you have V2 is what? Is 20 liter. V1 is what? Is 10 liter, right? So what happens if you multiply it here? So you have 1 times 8.314 times 298, right? So you have minus 2477.572. So liter cancel out liter, 0 cancel out 2. So you have ln what? 2. So how do you get ln 2? Natural logarithm. Is it okay? There's a word natural logarithm here. It's okay. This ln here, your calculator. So going to be minus 2477.572 times ln 2. You want to get your final answer. So minus 2477.572 times ln 2. So you have W equals to minus 1717.32 joules. So remember, the final unit is what? Is joules, right? So, but you can do unit conversion in the sense that, remember, I said my work is what? Joules. So how do we do unit conversion? So let me wipe this place out. So that you understand. Remember, my work is equal to what? Minus N RT ln V2 about V1 is okay. So the unit of what? Mole. The unit of N is what? Is mole. So let me leave the minus sign first. So here we have mole times. Now remember, R is what is gas constant, which is what? Mole, which is what? R equals to what? Joules per mole per what? Per Kelvin, right? So you are going to be times joules per mole per what? Kelvin times T is what is K. Remember, you have lean liter over what liter, right? They will cancel that. So you can say that mole cancel out mole. Temperature Kelvin cancel out Kelvin, right? What will be left is what this juice. So this is called the unit what analysis. Now, in this thermodynamics, this course here, thermodynamics here, as we move on, you need to what learn dimension analysis. How do you get your unit? It's very important you know all these things here. So you're not a baby again, or you're not like a junior class again where you know these things here. These things are highly important, and each of these things carries their marks because we must give them the reason why this is juice from that formula. Do you understand? So if you're following this video, put it in the comment section that you are actually not following this video. Then pause the video and try this for me. It's okay. Try something for me. So here the mode is 2. Now here we are using pressure. You understand? 5 atm, 1 atm at what 25 degrees centigrade. So you want to try this one for me. Now, one of the way you can learn very fast is by trying solving questions. And in my video, I always want to try questions. You guys, so you want to try it for me. So when you are done trying it, leave at the comment section that you are done. If you want to communicate with me directly, I'll drop my WhatsApp number. You can use to WhatsApp me or like send me question. I can respond to you no matter where you are from. Do you understand? I can actually respond to you. So if you need solution, probably a solution, and you need solution to this question, then you should DM me on my WhatsApp number. You understand? Then I'll respond to that. So let's look at the third one. If you look at the third one, you see that a thermodynamic system contain 1 mole. You understand? Of an ideal gas. So the numbers of mole is what? Is 1 mole. 1 what? Moles. Right? A thermodynamic system contain 1 mole of an ideal gas at the temperature here is what? Is already in Kelvin, 273 what? Kelvin, right? Now, look at the pressure here. So here we have pressure equals what? 1.0133 exponential 5 Newton per meter square, right? Now, the system is subjected to 10 times reversible increase in volume. Now, you can say because they didn't give you what volume, but they say that the system is subjected to what 10 times. That is, the final volume is 10 times what the initial volume. That is meaning. So you can say let V1 equals what V. It's okay. That is meaning. Let V1 equals what V because you are not actually giving you what value. And say that the final that is the system. The system is subjected to 10 times reversible increase in volume at constant temperature. So it's going to be V is going to be 10 of this V. Just so this is what you are going to make it of. So they're asking now what is the work done. So you are going to use W equals to minus N arrow T ln V2 over V1, right? So if you should impute your values, W equals to what? Minus, here we have 1 times, here we have, remember, R is gas constant, which is what? R here equals to what? 8.314 joules per mole. Okay, so this should always be in your mind. So here we have 8.314, right? Times. My T is what? 273. Then ln. V2 is what? Is 10 V over what? V, right? You cancel out V, you cancel out V. Just so here we have W here. W here we have minus. So let's multiply them together. So it's going to be minus 1 times 8.314 times 273 ln what? 10. So that's what you're going to do here. So you have minus 1 times 8.314 times 273 times in what 10. So you have W here equals to minus 5226.23 joules. That is what answer. If you are following this video, please leave it at the comment section that you're actually following. If you have any question, leave it at the comment section. Please, if you are not subscribed to the channel, please endeavor you subscribe. That is the only way you promote this channel here. And always leave your comments at the comment section. What do you think? Is this video helpful? Leave it at the comment section that this video is what is helpful. So we are done with what we do. What isothermal reversible. Let's see if I have another one here. Okay, so these are all the questions we are going to solve in this video. You understand? So, but in my future video, we are still going to solve more questions related to this one here. But now we have done what isothermal reversible expansion of what of ideal gas calculation. The next one I want to look at is one of the most critical aspects when it comes to what the thermodynamic basis for calculation, which is called change what internal what energy. So let's get into it. Let's look at what change what internal what energy. Now, when it comes to system, there's always what internal energy of that system, right? The summation of all the possible kind of energy in a system is called internal what energy. And when you talk about change internal energy, change internal energy, what delta E is equal to what Q plus W. Please, now this stuff is one of the most confusing aspects when it comes to what thermodynamics what calculation, because sometimes you see it as minus, sometimes you see it as negative, positive, right? I have to clarify that in this video. You get, so make sure you follow me through this video here. So this is called internal energy. It's called internal energy. This is called now as what quantity of heat. Quantity of what of heat. Okay. Then W is equal to what work done. It's okay. Now we have to call now let's look at what the heat, quantity of heat. Let's look at what quantity of heat. Now look at quantity of heat. Now, when a reaction happens, there are two things that happen to the system. Is heat is what is absorbed or involved, or it is what is taken in, or it is what is given out. So we have two types of reaction here. We have called exothermic reaction and what endothermic what reaction. So now let me look at what first one, endothermic reaction. It's okay. Now, in a endothermic reaction, that is, heat is absorbed. Either heat is what technique. So the system absorbs it from the surrounding. Do you understand? So whatever endothermic reaction, that is, it is taken in, right? So Q is always equal to what positive. Q is always equal to what positive. Now, when it comes to what endothermic what reaction, Q is always equal to what positive. Do you understand? Now, let's call exothermic. Exothermic what reaction. Now, in exothermic reaction, heat is given out. It flows from system to the what surrounding. It means that here, endothermic reaction, system is gaining heat. You understand? From the surrounding. In exothermic reaction, system is losing heat. It is being lost. So you can say exo means what? Loss of heat. And whenever what heat is being lost, Q is always equal to what negative. It's very, very important to know this one here. Then look at what work done. Very important. We have talked about work done, expansion, and the rest. So here we have work done. Work done. Now in the work done, which is what W here, it's very important here. Now we have to call compression. Now in compression, work is done on the system. So here we have compression. Idea. So in this compression here, work is done on the system. Work is done on the system by the surrounding. Just that the system is gaining work. Work is done on the system. compressing, you are compressing what the system. So work is done. Let's say work work done on the what system. It's okay. Work done on the system. And whenever work is done on the system, I there. Now, look at something here. They are always confused. We are going to look at various questions in this other one here. So now whenever work is done on the system, whenever work is done on the system, when work is done on the system. Now, work done on the system. So whenever I say work is done on the system, you're talking about W equals to what? Positive. It's okay. Work done in the system. Work is equals to what? Positive. Work done in the system. Now we have to call expansion. Expansion. Are you there? Expansion. In the expansion, work is done by the system. So work done by the what? System. It's okay. Work done by the system. And whenever work is done by the system on the surrounding, do you understand? You need to differentiate these things here because they are highly confusing. So work done by the system. So you got to be W is equal to what? Minus. That is it. So we have to solve the question how to calculate change in internal energy. Do you understand? We have to look at various what question here. So this formula we are using, this is called general what formula. Change internal energy equals to what? Q plus what? W. And endothermic reaction, exothermic reaction, compression, we have what called expansion. So now let's start looking at some questions and I can start applying this to solve problem when it comes to what? Change what? Internal what? Energy. Do you understand? So let's go into it. Let's look at what this set of questions on the board here, and this should be what? This should clarify you in your understanding how to solve questions when it comes to change what internal energy. So let's look at what the first one is that in the expansion of a real gas, understand that my delta E is always equal to Q plus what W. This should always be in your mind. It's okay. Delta E equals to Q plus W, right? In the expansion of a real gas, it was found that 185 kilojoules of heat was lost. Heat is lost. And whenever it is lost, it's called exothermic reaction. And what is exothermic reaction? Is it positive or negative? I'm asking you. Negative, right? Nice one. So that is my Q here. You're going to do what? Minus 185 kilojoules. Can you see that? Do I see that? It was found that 185 kilojoules of heat was lost. So it's an exothermic what reaction, and exothermic reaction is what is negative. So the quantity of heat here is what is minus 185 kilojoules of heat. Hope you understand. That is one. Now by the gas, when the work done by the gas, remember I told you that we have two types of work. Work is done on the gas. Let me ask you here. Let me see if you can actually what you remember. When work is done on the system, is it compression or expansion? Answer. Leave that in the comment section. When work is done by the gas, no, when work is done on the system, when work is done on the system, is it compression or expansion? Compression, right? Work is done, and whenever work is done on the system, is what is positive, right? Nice one. Now, but here they see that by the gas, when work is done by the gas, so we have what called work done on the system or on the gas, and work done by this gas. Now, when work is done by the system or by the gas, the system can be the gas. You understand? When you talk about system, you are talking about the gas. You understand? So work done by the gas is called expansion, and expansion is what is negative. Do you understand? So here we have W here is equal to, now because work is done by the gas is expansion, which was minus 135 joules, minus 1350 kilojoules. It's okay. Let's now calculate what is change what internal energy. So like what I said, this question might actually be confusing, but you need to understand the process. You need to understand what we call exothermic reaction, endothermic reaction, compression, and expansion. If you can understand this very well, and understand the question, you should be able to solve any question related to this one. when you apply this formula here. Do you get that? So they're asking you what is what change what internal what energy. Now, one thing I want to understand here is that now the unit here must be uniform. If here is joules, here must be what joules. If here is kilojoules, here must be what in kilojoules. Now, it is what commonly have it found in the exam. They will give it what in different. Here can be kilojoules, here can be what joules. It is your duty to convert it what to joules or kilojoules. Do you understand? But understand that it must be the same. So since it's already the same, so we can do it like that. So here we have change in E, which is what internal energy, Q plus what W, right? So change in E equals to what? My Q is what? Minus 185. So you ignore the kilojoules here. Plus, remember there's this plus here, plus. Now W is what? Minus, so here we have minus 1350. Do you understand? So here we have minus 185 plus x minus is what? Minus 1350, right? So minus this minus that, what you get? Minus 185 minus 1350. Here we have minus 1535 kilojoules. That is the what answer. Do you understand? So pause the video and try this one for me. Let me see what you can do. Leave your answer at the comment section. Try some here. I'm going to give you some few minutes for you to try this. I'm going to give some few minutes to try this. So go ahead and see if you are going to get that answer. Hope you have tried. See, when I say you should try, endeavor you try, because now someone say how bad habit is that. Their bad habit is this: when they finish watching a video or going for a class, they never want to revise, and that is their big problem. You get now. What makes you a better student is that after a class you know what to solve. I'm in a class. On the most serious, I don't trust you that after this video you are going to look for more questions to solve. So I don't assume that this is the only question you are going to solve for your exam. So that is why I give you questions upon questions. You get, but if you don't want to be very, very good at all in your academics and you want to score very well, it is your responsibility to look for tough questions that will tax your brain and solve. So if you're following my online class and I ask to solve, don't just. I know that some of you watching this video now, you are on your bed watching this video, right? You are not doing yourself a favor. You are supposed to be. You are supposed to sit as a class, being with your reading in the seat on your reading table, follow step by step. If you have any question, leave at the comment section. I will respond to that. That is how to learn. Get so go ahead, solve it for me. Leave your answer at the comment section. I'm not going to solve this one. Leave your answer at the comment section. I want to see. So now let's solve the last one here. What is the change in internal energy of the system for a process in which a state absorb it, in which the state absorb 140 joules of it? So it is absorbed, right? It's called endothermic reaction. Endothermic reaction, right? Now, when it is absorbed, it's called endothermic reaction. So my Q is positive. So here you have plus 140 joules, right? From the surrounding, and that is the system does the work and does 85 joules of work on the surrounding. So work is done by the system, and when work is done by the system, it's called expansion. Do you understand? Work done by the system. So here we have W, and whenever work is done by system, is what is negative. Negative. So here we have minus 85 what joules. Do you understand? So they ask what is change in what internal energy. What do you want to change your internal energy? So here we have change internal energy equals to what? It's equals to Q plus what W. So impute your values there. Q is what 140 plus minus. Here we have it what 5, right? So what we have 140 plus x minus what minus 85. What is the answer? So you have 140 minus 85. Here we have plus 55 what joules. So you can see how far we have gone, but we still have a lot of questions under this one topic. You get, so I don't want this video to be too lengthy. So in my next video here, I want to show you how you can use this one to solve more difficult problem. You get, If this video is helpful, please don't leave this video without you commenting and liking. And if you are not subscribed, please endeavor you subscribe. Now, what I want to do, if you really benefited from this video, now what I want you to do for me, because you're not paying me, you get. Now the only payment I want from you is what? Copy this link now and share it to your various group. Share it to your friends who are doing this course, this thermodynamics. Do you understand? And I will really appreciate that. Please tell your friends about Chemicals TV. It's just a way to help you understand chemistry faster and better. So if you can be in my physical class, man, fine. Make sure you be in the physical class. You get. Thanks for watching. This was day 2. In our day 2, we do other one. So tomorrow we continue what in our video. So always turn up by 9 p.m. Nigeria time. 9 p.m. Nigeria time. So my WhatsApp number will display on the screen, or you can see a link that will get you, that will send you directly to me on WhatsApp. If you have any question, only leave it at the comment section, and I will always be of help to you. Thanks for watching. See you in tomorrow's class.